Maybe in the last class we just discussed about the differences between linear queue and circular queue. So I'm just starting with the linear queue. Okay, so queue is a data structure, and what is the difference between a stack and queue? In stack, only one end is open, so we can insert or delete data item from this end, but queue, both of these ends are open. Okay, so in one end we can insert data, and from another end we can delete the data. Okay, and the queue can be represented in three ways. One is linear queue, another is circular queue, and the third one is DQ, that is double end queue. And besides these three types of queue, you can use another one that is called priority queue. So the first one is linear queue. So if it's a queue with two open ends, let me just accept. Okay. So how this data structure works? I mean, what is the concept of queue data structure? If we have some data elements, that is 2, 4, 6, 8, 10, how this data will be inserted? How we can insert these data elements? So at first we have to choose which representation we want to use. This queue can be represented as array, it can be represented as linked list, or it can be represented as stack. Okay, so suppose we want to represent the queue in array data structure, which means that the size should be mentioned before storing the data item. Okay, so if the size of this array is 5, that means it can accept 5 data elements, and here insertion operation means NQ, and deletion means DQ. And which end should be used for insertion? The rear end, and from the front end we can delete the data element. So here if we take 5 space from the memory, suppose this is the memory address 0, the next one is 1, 2, 3 and 4. Okay, so the queue has 4 memory locations from 0 to 4, and here n equals to 5. And what about the upper bound? Upper bound is n minus 1, right? And if the first data is 2, then in which position we can insert the data item? Or before inserting any data item, we need to know, is it empty or is it full? What is the condition of this queue now? And from where we'll get to know it? If we perform an operation that is called is empty operation, and at that time we need to know what is the initial value of front pointer and the rear pointer. So why use these two pointer? One is front and another is rear. The front pointer will tell us which element is the first element, and rear pointer will hold the position of the last element, right? So here initially the value of front and rear will be -1. Why? Because now we are using 0 based indexing. What is the previous value of 0? The previous value of 0 is -1, and the next value of 0 is 1. If the queue is arranged in unit, if the indexing started from 1, at that time the initial value of front and rear will be 0. But here 0 is also a memory location, isn't it? So that's why the initial value of front pointer and rear pointer will be -1. Okay, and now if f equals to -1 and rear equals to -1, that means the queue is empty. So where will insert the new data element? In the first memory location, that is 0. So after inserting 2 in this location, now the queue has one element, and this is the front side of the queue and this is the rear side of the queue. So after the insertion, now the value of front and rear pointer will be increased by 1. What is the value of front and rear now? 0. Front equals to 0 and rear equals to 0. So this is the first element of the array. And now if we want to insert 4, 8, 10, 12, can we insert these 4 data elements at a time? Is it possible? Hello? Can we insert these 4 data elements at the same time?
No, ma'am.
It's not possible, because in queue, the NQ and DQ, the complexity is order of 1. So at first we can insert the next data element, that is 4, but before that the value of rear should be changed. Now the value of rear will be increased by 1. R equals to R plus 1, and the previous value of R is 0. So 0 plus 1 equals to 1. So this is the place where the new item will be inserted. So F equals to, what is the value of F? The value of F will not be changed because still 2 is the first data element, and now R equals to 1, that means 4 is the last data element. And in this way we can insert 8, 10, 12, but every time we have to increase the value of rear by 1. So after inserting all these data elements, now if we want to delete, which data element will be deleted first?
Ma'am, 2.
From this pointer value, we'll know in that. From this position 0, the data will be removed. So 2 will be removed from this queue, and now the value of front will be increased by 1. After the NDQ operation, the value of front pointer will be increased. Okay, so now 0 plus 1 equals to 1. So this 4 is the first element of the queue, and which one is the last element? R equals to 4, that means 12 is the 4 data element, right? So now in this queue there are total 4 elements, but the size of the queue was 5. What is the size of the queue? 5, but it has only 4 elements from 1 to 4. This is now a garbage value over here. We can't use this space because we are using a linear queue. In linear queue, the memory, we cannot reuse the memory location. Right? That means after that, if we want to insert 15, it's not possible. At the time of this insertion, it will print a message overflow. So when it will show that message? When R equals to n minus 1, right? What is the value of R? 4, right? So 4 equals to n equals to 5, 5 minus 1 equals to 4. That means the queue is full. Right? Hello?
Yes, ma'am.
Is it clear why a new item can't be inserted here? Because for insertion operation, the rear value should be increased by 1. And here the rear value is 4. If we increase it, then the value will be 5, which is not possible here. The array size is fixed. It can take maximum 5 elements, and this is the 5th element. 12 is the 5th element. That's why if this condition is true, that is R equals to n minus 1, that means the queue is full. And we can solve this problem where in circular queue, isn't it? So what is the concept of circular queue? We can take the same data, that is 2, 4. These are our data, 2, 4, 8, 12, and 10. So how many data elements are here? 2 data elements. And what is the initial value of front pointer and rear pointer? When the queue is empty and the first memory location is 0, that means F equals to minus 1 and rear equals to minus 1. And after inserting the data 2 in memory location 0, now the value of front pointer and rear pointer will be changed. So what is the new value of front? 0, and the value of rear is 0. And after that, in the same way, we can insert these 4 elements. Before inserting a new item, we have to increase the value of R by 1. Then these items can be inserted. 4, 8, 10, and 12. Now in this queue, the value of front is 0, which means that 2 is the first data element and rear equals to 4. That means 12 is the last data element. And is it full? Here R equals to n minus 1, right? What is the value of R? R equals to 4. That means R equals to n minus 1. This condition is true. So the queue is full. Right? That means we can't insert 15 in this queue. But now if we want to delete an element from the queue, that is the first one, then the value of 0 will be, the value of front will be changed. After deleting 2 from the queue, what will be the new value of front? 1, because now 4 is the first data element. After that, if we delete another data item, that is 4, then the front pointer value will be increased by 1. So now 8 is the first data element, is in memory location 2. isn't it? So look at the queue now. The size of the queue is 5, n equals to 5, but how many elements the queue actually has? Only 3 elements from 8 to 12. The queue has only 3 elements because front equals to 2 and rear equals to 4. That means these two spaces are empty space. And if we are using circular queue, that means now we can reuse those memory location. How? Now if we want to insert a new data element 15, and here the number of available spaces 2, so in which location we are going to insert that new item 15? In position 0 or in 1?
I mean, no one.
In position 1.
Position 0.
In position 0. Okay, so what is the condition here? What is the condition that you can apply here? Or how we'll get to know it that the queue is not full and we can insert, or this queue can accept new data element. There is an equation, there is a condition, that is if r plus 1 modulus n equals to front, that means the queue is full. What is the condition? If r plus 1 modulus n equals to front, that means the queue is full, then the new insertion is not possible. So here, if the last element is 12, that means r equals to 4. 4 plus 1 equals to 5. Modulus n equals to 5, right? So 5 modulus 5, and what is the value of front? Front equals to 2, because 8 is the first data element now. Okay, so is this condition true? 5 modulus 5 equals to 2. It's not true, because 5 modulus 5 equals to 0 and front value is 2. So these two are not true. So if this condition is false, that means the queue is not full. We can insert, or the queue can accept some other new elements. Okay, but if there are multiple places available, then which one we should choose? Then again use another equation, that is the new value of r will be, now we can't increase the value of r by 1. For the new element, if we just write r equals to r plus 1, at that time what will be the value of r? The value of r will be 5, and this index is an invalid index. Here we can't take 5 because at that time the number of space, the number of element of this array will be 6. So that's why this index is invalid. So now the new value of r will be r equals to r plus 1 modulus n. Okay. So the previous value of r is 4. 4 plus 1, that is 5. 5 modulus 5 equals to 0. That means in this position 0 we can insert 15. Right? So here we can add 15, and if we want to add another data item, that is 17, where we'll insert it? In the next data, in the next position. Okay, so here we can. But remember, in circular queue we didn't actually apply the rule r equals to r plus 1. Which equation will be applied here? R equals to r plus 1 modulus n. So when r equals to 0, after inserting 15 in position 0, r equals to 0. And what about front? This 8 is the first element, so front equals to 2. So now, in which position we'll insert it? There is only one available space. Now, so we can use this equation. R equals to r plus 1, that is 0 plus 1 equals to 1. 1 modulus 5 equals to 1. So this is a place where the next item 17 will be inserted. Is that clear? What is circular queue? Is that clear?
Yes, ma'am.
What is actually the logical representation of circular queue? Look at this, how we are actually reusing those spaces. This is a circular queue, and how many spaces the circular queue has? 5 space, right? So this is for 0, 1, 2, 3, and 4. So initially the queue has how many elements? 5 elements, that is 2, 4, 8, 10, and 12. And after deleting some elements from the queue, now if it is the last element, r equals to 4. If 12 is the last element, now the new element can be added where? In the next element, in the next position actually, right? And after adding 15 here, now another available space we can find in position 1, right? When r equals to 0, after that we can insert another data item in this position, just like it's creating a circle actually. So is it clear what is the difference between linear queue and circular queue? Is it clear?
Yes, ma'am.
Yes, ma'am.
And so now the next one will be DQ. So another type of queue can be used. It's called DQ or double-ended queue. And so just think about a linear queue. If it's a linear queue, then these two ends are open, right? If it is the front end and if it is the rear end, the rear end will be used for inserting the data element and the front end will be used for deleting the data element, right? That is linear queue. And now here suppose we have some elements 5, 7, 9, 11 and 13. For inserting 5 elements, we have to at first mention the size. So if it is a linear array, then the size will be 5 for taking 5 elements 0, 1, 2, 3, 4. Okay, so here we can insert 5, 7, 9, 11, 13. And how the data element was inserted? Every time the real value was increased by 1, right? Here f equals to 0, that is 5 is the first element, and real equals to 4. That means 13 is the last element. Okay, so in linear queue, if we delete the first element, suppose 5, 7, 9, at that time these spaces will be wasted. That means we can't use the space. The compiler will just, consider this as garbage location, so you can't actually use these spaces. So here front equals to now 3 and rear equals to 4. But what about circular queue? In circular queue, we can use these spaces. We can use the empty spaces, right? But in which end we are actually inserting that and deleting? In linear queue, the insertion and deletion can be done only in one end. But what about the circular queue? When the last data element is 13, after that, if we want to increase another item, suppose 15, in which position it will be inserted? In the first position, and this is our front end, right? But we are inserting the new element in the front end, but we are actually considering this as the rear element, isn't it? Because we are changing the value of rear, after that we are inserting the new data element. So can you say that here the insertion can be done in both the front and rear end in circular queue? Do you get my question? Hello?
Ma'am, will you please repeat again?
This is the linear queue, right? And we can't insert any data item from the front side, or we can't delete any data element from the rear side. That is linear queue. But in circular queue, suppose this is 0, 1, 2, 3, sorry. So this is our last element because r equals to 4. Okay? And this is the front side. Here suppose front equals to 1. So this space is available now. Okay. Now if we want to insert the data item, what do we usually do in linear queue? We just increase the value of r. Why? Because in the rear end we can insert the data item. But in circular queue, when r equals to n minus 1, that means the queue is full, but still we can reuse the available spaces, right? And then we can modify the equation of r, that is for the next position we can find out the location of r by using the equation r equals to r plus 1 modulus n. At that time, in which position we can insert? In position 0, but this is the front end of the queue. Okay, so does that mean we are inserting the data element in a circular queue in both this front and rear end? Hello?
Yes, ma'am.
I don't know know whether you are listening me or not. I'm confused.
Ma'am, actually here Azan was going on, so it could be.
Sorry, there are.
Ma'am, Azan, actually Azan is still working. So, শুনতে পাচ্ছি।
What about the others?
Yes, ma'am. We are here.
First, tell me, do you get my question? Is it clear what I'm actually?
Yes, ma'am.
I just want to know whether in if it is circular queue at that time after inserting the data element in the last position, and if the front sides are empty, if we can find some available space in the front side of the queue, that means we can insert the data element in those front side. So does that mean we are inserting the data element in both ends?
Yes, ma'am.
Yes. Okay. So now this is DQ. That means double-ended queue. So what is the difference between DQ and this linear queue? The difference is in linear queue only one end can be used for insertion and deletion. But in double-ended queue, both these ends can be used for insertion and deletion. That means from the front end, we can delete the data element or we can insert data element. And if it is a rear end, we can insert data element in this end or we can delete data element from the rear end. That's why this type of queue is called double-ended queue. Insertion and deletion is possible from the both sides. Okay, so here we will get four types of operation. One is we can insert the data element in the front, which is not possible in linear queue, and then we can insert the data element in the rear, which is actually usual case, and then we can delete data element from the front, and the next one will be delete data element from the rear. And this is the difference between double-ended queue and linear queue. In linear queue, we usually use these two operation: insertion at rear and deletion from front, right? But in double-ended queue, from this end or in this end, we can insert data, and from the rear end, we can delete the data. That's why it's called double-ended queue. And this double-ended queue can be divided into two parts. One is called input restricted queue and another is called output restricted queue. Okay, so when the queue will be called input restricted queue, input restricted, that means insertion can be done only in one end. We can insert a data element at the rear end, but from this front end, we can insert or what is input restricted queue? From the rear end, we can insert, and from this front end and from the rear end, we can delete the data. Okay, and then what about output restricted? That means we can delete the data element from one end, but we can insert from two ends. Usually from which side we delete the data? From the front side. So from the front side, we can delete the data. But what about input? Now, in this end, we can insert the data, and from the rear end, we can insert any data. Is that clear? What is the difference between input restricted and output restricted queue? In input restricted queue, input will be done in only one end. In which end? Only in the rear end. The insertion will be done in the rear end. And what about the deletion operation? We can delete the data item from the front side and we can delete the data item from the rear side. And in output restricted queue, the deletion will be done from one end, only from the front end. And we can insert the data element in the front side or in the rear side. Is that clear?
Ma'am, will you repeat again input?
Hello.
Ma'am, will you repeat again?
Okay. So there are two types of double-ended queue. One is input restricted. What is input restricted? That means we cannot use both the end for insertion purpose. input restricted, that means use only one end for insertion, but you can use both the end for deletion. So here we use only one end, the rear end for insertion, but we can use both the rear and front end for deletion. And the next one is output restricted. That means now deletion can be done from one end, but both this end can be used for insertion. So we usually delete the data element from the front side. So here deletion is possible from the front side and insertion can be done in both of these side. Clear?
Yes, ma'am.
Okay, so now we will execute all these four operations on a double queue or double-ended queue. Okay, so we can take same length queue, that is the length is 5. So 0, 1, 2, 3, 4, and we'll implement this double-ended queue by using a circular queue. That means we can reuse the memory spaces. So here n equals to 5 and this queue is a circular queue, and how we can insert and delete from both of these ends. Just think about a linear queue. If the operation is NQ7, if the operation is NQ7 and if the queue is empty, we can insert the data element in the first location here. Okay, so after inserting 7, the front value and rear value will be 0. Right? And if it's a linear queue or a circular queue, then where we will insert the next data element 8. Obviously in the rear end, the rear value will be increased by 1, then we can insert the data element in this location. But here in double-ended queue, the insertion and deletion will be mentioned. That is, in which end we want to insert the data or from which end we want to delete the data. So now the instruction is insert from the front or insert at the front. So insert 8 at the front. So now what is the value of front? Front equals to 0. That means 7 is the first data element. And then rear equals to 0. That means 7 is there is only one element. That's why the pointer value is same. So if we want to insert a data element 8 in the front side, how we can do it? Because 0 is the first index of this queue, right? We cannot insert a data element here. We cannot insert it because at that time the position will be -1, which is invalid. Here the size of this queue is 5 and the index started from 0 and the last one is 4. So if we want to insert a data element in the front, that means this 7 should be moved to the right side and then we can insert the data element 8 here. Is it clear? If the operation is insert at front, which element do we want to insert? 8. Okay, but already in the first location 7 is stored, that is the first data element. So if we want to insert another one, we cannot increase the array size or we cannot just add it where in memory location -1, because the first memory location is 0. So if we want to insert it, can we insert it in this position 8? Is it possible? Can we just move the data element in this way? What do you think? Is it possible? Can we just change the data size? I mean the position of the data element? You have to respond. Is it possible? The way I have inserted the second data element, how? By just moving the first data element in the right side and then inserted the new element. Is it correct?
No, ma'am. I think
No, it's not correct. So which rule or how we can insert the new data element? If we can't take -1, then how the data element will be inserted? Obviously in the last location. If front equals to 0, if the first data element 7 is stored in memory location 0, and if the operation is insert at front, that means now it will be inserted in the location where in -1. Here n-1 is 4, so 8 will be inserted here and the new value of front will be 4. This is double-ended queue, that's why insertion can be done in the front side and the rear side. And after inserting 7 in this queue, the value of front is 0 and rear equals to 0. Right? And after that, if we want to insert a data item, suppose insert 9 at the rear, at that time we can simply increase the value of r by 1 and then we can insert 9 in location 1. But now the instruction is insert front, right? Insert at the front. But already the front has the data element 7. So how we can change the value of front pointer? Now it will insert the data element in position n minus 1. After that, now the next operation is insert at rear. So in which location we'll insert it? Insert at rear and the value is 10.
Ma'am, at location 1.
Very good, location 1, because r equals to 0. Here rear equals to 0. So for inserting the data element in the rear side, we just have to increase the value of r by 1. Now the new value of r is 1, where 10 will be stored. And after that, if the operation is insert at the rear and the data is 12, so where it will be insert? In location 2. After that, the value of r will be 2. So this is insertion. Now we know how to insert the data element in the rear side as well as in the front side. Okay, so what about the deletion operation? Now, here in this queue, what is the value of front and rear? Now 8 is the first data element, isn't it? So front equals to 4. And which one is the last data element? 12. So r equals to 2. And we always delete the data element from the front side, but this is double-ended queue. That's why we can delete the data element from the front as well as from the rear side. Suppose the next instruction is delete from front. Delete from front. So which element will be removed now? Here the front pointer value is 4, which means that 8 is the first data element. 8 is the first data element. So after deleting 8, now how the front pointer value should be changed?
Front will be 0.
Very good. If the front element is now 8 and its position is 4, which is equals to n minus 1. The first element is stored in the location n minus 1. After deleting it, now the new value of front pointer will be 0. So now 7 is the first element of this queue. After that, if we want to delete a data element from the rear, the next instruction is delete or dequeue from rear. What is the value of rear? 2. And in insertion, how we insert a data element in the rear side? By increasing the value of r by 1, isn't it? If it is insertion operation, at that time we can increase the value of r by 1 and then we can add the next element in position 3. But now the instruction is deletion from rear. R equals to 2, so that means we have to delete the element 12. After deleting it, now how we can set the new value of r? Now
R equal to 1.
Operation, it will be r equals to r minus 1. That is r minus minus. After deleting 12, now the rear value will be increased by 1. The position will be changed. So r equals to 1 and now 10 is the last element of the queue. So this is the queue after performing some operation. Now tell me how many elements the queue has. It has only 2 elements and the front or first element is 7 because f equals to 0 and the last element is 10 because r equals to 1. Okay, so now again, if we want to insert in the rear, how we'll do it? There are total 4 operations. I'm writing it here. One is insert at rear, and then insert at front, and then delete at front, or the next one is delete from the rear. In linear array, we usually use which 2 operations? This one, insertion at the rear and deletion from the front. And how we insert the new item? By using this rule, r equals to r plus 1. Right? And what about deletion? After deleting any data element from the front pointer, the value of front, how it is changed? we usually increase the value of front by 1, right? Now when we are inserting the data element in the front side, what is the value of front? Front equals to 0. That means 7 is the first data element. And now if we use this equation, that is f equals to f plus 1, I'm writing the queue again. This is our queue with two elements. One is 7 and another is 10. And which one is the first element?
7.
7 is the first element because f equals to 0. And what about rear? Rear equals to
1.
okay. And if we want to insert data in the rear side, how the pointer value will be changed? The rear value will be increased by 1, and here we can add 12. Now the new value of rear will be 2. That is insertion at rear. Just increase the value of rear pointer by 1, then insert the data. And another operation is insert from front. So how it will be executed? Insert from front.
Ma'am, n
We
minus.
can apply two rule. We can apply two rule. Okay. Suppose 7 is already deleted from here. If 10 is the first data element, that means if f equals to 1, there are total two rules. Suppose 7 is deleted. So which one is the first element now? 10, which is in position 1. After that, if we want to insert a new data element in the front pointer value will be changed in this way. Front equals to front minus 1. And here f equals to 1. So now the new position of f will be 0. So here we can insert 14. Is that clear?
Yes, ma'am.
Okay. Now when 14 is the first data element and the first index is 0, after that if we want to insert another data element in the front, what will be the new value of front?
F equal to n minus 1.
0. And then we have to apply this rule. The new value of front will be f equals to n minus 1. Now the next data element 16 can be stored here. Is that clear?
Yes, ma'am.
Okay. And now another operation is left, that is deletion rear. We usually delete data element from the front and then we increase the front pointer value by 1. But now we have to delete a data element from the rear side. And what is the value of rear pointer? Rear equals to 2, which means that 12 is the last data element. So here new value of rear will be r equals to r minus 1. After deleting 12 from this queue, now the new value of rear will be 1. Is that clear? Is that clear?
Yes, ma'am.
Okay, now another thing can happen. Suppose here the rear value is 14. Suppose this is the queue with only two elements and one element is in this position 0, 14, and another element is here 16, which is in memory location 4. Okay, but front equals to 16, which front equals to 4, which means that 16 is the first element and rear equals to 0, which means that 14 is the last element. Now after that, if we want to delete a data element from the rear, then what will be the new value of rear? Just look at the queue. It has only two elements. F equals to 4, which means that 16 is the first element. R equals to 0, that means 14 is the last element. And if the operation is delete from the rear, that means after deleting it, the value of rear will be r minus 1. But here, if we write 0 minus 1, the new value of rear will be minus 1, which is invalid. So after deleting 14, what will be the new value of r?
Ma'am, 0 plus 1.
No, it's not 0 plus 1 because in this location we don't have any value, we don't have any data. Which rule we used when f equals to 0 for insertion in the front? Which rule we used? If if the first location is already full, then we have to insert the data element in the last location, in the n minus 1 location. So here, after deleting the data from the, if after deleting the last data, this 14 is the last data element. Now the new value of r will be n minus 1. N minus 1. That means now the queue has only one element and the value of front is 4 and rear equals to 4, because we know that when the queue has one element, at that time the front pointer value and the rear pointer value will be same. Is that clear?
Yes, ma'am.
Ma'am.
So this is the concept of double-ended queue. Double-ended, that means you can delete or you can insert in both the end, front and rear. Okay, but you need to know the rule, that is how we can insert the new data element, how the value of front and rear pointer can be changed. Okay, so how many types of queue we discussed so far? 3 types of queue: linear queue, circular queue, and double-ended queue. The first one is linear queue, right? And in linear queue, we can insert only in the rear end, and the deletion is possible from the front end. And another characteristic of linear queue is we cannot reuse sorry, what I'm saying. Suppose it's an empty space. Can you use it? No. So memory cannot be reused in linear queue. And another type of queue is circular queue. So what is the characteristics of circular queue? Just like the linear queue, we can insert the data element in the rear side and we can delete the data element from the front side. But after deleting some data element from any position, if we want, we can reuse the data element. We can reuse the
Empty space.
empty spaces. That is circular queue. Okay, and the last one is double-ended queue. So how many operations are possible here? 4 types of operation: insertion at rear, insertion at front, deletion from front, and deletion from rear. So each of these end can be used for insertion and deletion. But if it's mentioned the queue is input restricted queue, at that time you can insert in only one end and you can delete from the both end. And if the queue is output restricted queue, that means deletion can be done from one end, but for insertion purpose you can use the both end, front and rear. Is it clear?
Yes, ma'am.
Okay, so I'm just giving you some data, so you have to perform this operation on a circular queue. Okay, suppose the circular queue is actually a double-ended queue and its size is 5. 0, 1, 2, 3, 4. And the queue is empty, that means f equals to -1, r equals to -1. Okay, and the operations are in queue front, okay, just 6 operations. In queue at the front side, then in queue at rear, again in queue at rear, then DQ from front, again DQ from front, then in queue in the front. Okay? Can you solve it? Hello?
Uh,
I'm not getting any response. Can you solve this problem? Can you execute these 6 operations on this double-ended queue? Hello.
Ma'am, I have to try.
Okay. So the first one is, or I'm solving it, no problem. In queue from where and front. And what is the value of front and rear now? Front equals to -1 and rear equals to -1. Okay. So if we want to insert 17 in the front side, that means we can use the first position 0. So here we can insert 17. And now after inserting 17, the new value of front and rear will be 0. So front equals to 0 and rear equals to 0. Now the next operation is NQ at rear. And for this operation, what is the rule we have to use here? R equals to R plus 1. That means the new value of R will be 0 plus 1 equals to 1. So here we can insert 21. But the front value will not be changed because still 17 is the first element. And then the next operation is NQ rear 28. Again, the NQ operation in the rear end. So again, insert the value of, increase the value of R. So what is its new value? 2. And here in this position, we can insert 28. Now the next operation is DQ front. DQ front. So here 17 is the
First element.
front element. 17 is the first element. And after deleting it, now how the value of front pointer will be changed?
+1. 0 plus 1.
0 plus 1. So now after deleting 17 from this queue, 21 will be the first element and its position is 1. So F equals to 1. Okay. Now again, the next operation is DQ front. So which element will be?
21.
21. After deleting 21 from the from the front, now the front pointer value will be increased by 1 because 28 is the first element. So F equals to 2. Now again, the queue has only one element, 28, because front equals to 2 and rear equals to 2. Now the next operation is NQ front. That is insert 31 in which end? In the front side. Here front equals to 2 and rear equals to 2. So how the value can be changed?
F equal to F minus 1.
Very good. So now we have to use the equation F equals to F minus 1. Here F equals to 2, right? So in this position we will insert the new data element 31. After that, if we want to insert another data element in the rear, and suppose that data is 34. So in which position we will insert it?
Ma'am, R equal to R plus 1.
R plus 1 equal to 3.
Very good. R equals to R plus 1. So now in this position we will insert 34. Suppose now the next operation is DQ from rear. DQ from rear. So how this operation will be executed? DQ from
R
rear.
minus 1.
R minus 1. So now again, after deleting 34, the value will be, the value of rear will be 1. R equals to 1. Okay. Now the next operation is insert at front. Insert at front. And we want to insert the data 10. So where it will be inserted? Insert
0.
at the front.
0.
Very good, 0. Again, F equals to F minus 1. So in this position, we will insert 10. And now the new value of F will be 0. After that, the next instruction is insert at front and the data is 20. The next instruction is insert.
So F equal to n minus 1.
N minus 1. Front. Very good. Here F equals to 0 and now we cannot decrease the value of front pointer. Right, so which position will be used now? The new value of front will be F equals to n minus 1. So here we can insert 20. right? And after that, if the next instruction is again insert 30, so in which position will you insert it? In position 3. So in this way, we can insert or delete the data item from any of this front end rear. Is it clear what is double-ended queue?
Yes, ma'am.
Okay, and this is end of this
Yes,
chapter
ma'am.
queue. So how many things actually we discussed in this chapter? Mainly about queue, that is what is queue, or how many operations can be done on queue. There are 5 operations, that is enqueue means insertion, dequeue that is deletion, then pick operator which will return the value of front pointer, and then is empty to check whether the queue is empty, and the last one is full, right? And then we discussed about some types of queue, that is linear queue, circular queue, and the last one was double-ended queue. So do you have any problem in this topic, in any of this topic? Linear queue or circular queue or in this one?
No, ma'am.
No. Okay. So in linear data structure, how many topics are actually included in linear data structure? There are four types of, right, linear structures, that is array, linked list, stack, and queue. Okay, so in the next class we will start non-linear data structure, that is graph. Graph or tree, you can just start in one of this. Okay, so now please response. 1.